This presentation presents forensic science challenges related to cloud architecture. We will discuss challenges related to multi-tenancy, data segregation, and provenance. Challenges range from deletion in the cloud and recovering overwritten data to evidence segregation and chain of custody. As you will see, forensic acquisition and analysis is not as cut and dried as it is with on-site computer networks. Before we delve into cloud forensics and their challenges, let's briefly define what we mean by the cloud. Cloud computing is the on-demand availability of computer system resources, especially data storage and computing power, without direct active management by the user. Large clouds often have functions distributed over multiple locations, each location being a data center. It is for this reason that the cloud presents many forensic challenges. Evidence goes through a process. Evidence must first be identified, collected, transported, and then stored, all the while following a chain of custody. From there, it is analyzed, interpreted, and attributed to the case at hand, where it is presented in some type of proceeding, whether related to corporate or legal proceedings. Finally, evidence is destroyed. This process is not perfect and applies to cloud evidence gathering as well. The difference from standalone systems to the cloud is in how and the challenges that is inherent in data acquisition in the cloud. Faults consist of intentional or accidental making of something in a case. Here you see several items ranging from content and context and process elements to logistics as timing, ordering, and location. The line between what is consistent and inconsistent becomes confused, and corroborating content may not fully exist. Not all faults lead to failures, though. It is important to realize that there are two types of failures. False negatives are items that should have been found and dealt with in the process but were not, while false positives are things that should have been discarded or discredited in the process but were not. In the cloud context, the faults and failures may extend to multiple computers in multiple locations under the control of multiple parties. Thus, the opportunities for faults and failures are extended in the cloud. Multi-tenancy is a software architecture in which one server hosts a multitude of different virtual environments for unrelated organizations or tenants. A multi-tenant cloud is a cloud computing architecture that allows customers to share computing resources in a public or private cloud. Each tenant's data is isolated and remains invisible to other tenants. In a multi-tenant cloud system, users have individual space for storing their projects and data. Multi-tenant architectures are found in both public cloud and private cloud environments, allowing each tenant's data to be separated from each other. For example, in a multi-tenant public cloud, the same servers will be used in a hosted environment to host multiple users. This is a challenge in that data segregation must be accounted for, and limiting access to one tenant may be problematic because access is for one virtual environment consisting of multiple data content for multiple users. So, what are some of the challenges facing forensic data collection in the cloud? Evidence is data. What segments data from other data is not just the data. In cloud forensics, as with end-user forensics, this includes storage location, user access, and time access, among others. These challenges include discovery of computation structure, attribution of data, stability of evidence, and presentation and visualization of evidence. Multi-jurisdictional law is escalating the challenge of cloud forensics, particularly with data segregation. Provenance refers to the record describing the origin and other historical information about a piece of data. An advanced data provenance system will give forensic investigators a transparent idea about the data's lineage and help to resolve disputes over controversial pieces of data by providing digital evidence. In the cloud, provenance may not be limited to one location, as with an end-user system. Factors such as multi-tenancy and different distributions can reflect time and access data. This is problematic in that records of origin and history can be hard to identify and may not reflect a single entity. After you delete a file from your computer, the file will also be deleted from the cloud the next time your system syncs. At the same time, this is not a permanent, irreversible process. Most cloud storage systems allow you to restore a deleted file within 30 days. In Google Cloud Storage, customer data is also deleted through cryptographic erasure. This is an industry standard technique that renders data unreadable by deleting the encryption keys needed to decrypt that data. This is problematic because cloud service providers would need to grant authorization to recover deleted data. Deleting email accounts will also delete cloud storage, and that email account may not be recoverable, making the data on that cloud storage inaccessible or lost. Data will be distributed over several virtual environments. If a cloud customer no longer uses the space that the data resides on, then that space will be used by other tenants. Cloud service providers need to ensure that one client's data will not contaminate other tenants' data. This protects the proprietary value of various customers' data. Data may also be moved to other locations. The structure of the cloud virtual environments make it difficult, if not impossible, to recover overwritten data. Cloud-based computing is here in a big way and is likely to be here for a long time to come. From the perspective of forensic science, it adds several key challenges that have widespread effects. These challenges range from multi-tenancy and jurisdiction to data segregation, provenance, and recovering deleted and overwritten data.